Hi, I'm Mr. Heng. In today's video, we shall learn integration. Sometimes it is referred as anti-differentiation. Before this, you have just learned differentiations. So integration is the exact reverse process of differentiation. The integration is denoted by this integration sign. Can you see this? So in general, when you integrate, you shall get back what you have differentiated. Now we shall look at the formula. Let's look at the third formula here. This is the general formula that you shall use. So when you integrate, your answer shall be the power of x increased by 1. That means you plus 1. And you shall divide by the new power, not forgetting to add a plus c. So for special case, when there is just a 0, when you integrate, you shall get a constant. When you integrate a constant, that means a number, you shall get kx plus c. That means there is no x. So you integrate, you shall get x to the power 1, which we just show as kx plus c. Now we shall look at some example. So for 1a, you want to integrate 3x. So when you integrate, x in the question here, in the integration here, there is no power. But you know very well that this is power 1. So when you integrate, you shall get 3x squared over 2. Power 1 plus 1 will give you 2. Then you divide by the new power. And not forgetting to add a plus c. For 1b, you have a denominator consists of x to the power 3. You need to bring it as a negative power. So 1 over x cubed is changed to x to the power minus 3. When you integrate, your minus 3 plus 1 shall give you negative 2. Then you need to divide by negative 2. Then plus a c. So in order to get the positive index, the numerator x to the power negative 2, we shall bring it in the denominator. So your final answer shall be minus 1 over 2x squared plus c. As for 1c, when you see a square root or a third, you need to change it to fractional index. So square root is the same as x to the power half. Cube root, you shall get x to the power 1/3 and so on. So when we integrate, you shall get half plus 1 will give you the new power of 3 over 2. Don't forget to divide by the new power 3 over 2. So this is a complex fraction. We are simplify as 2 over 3, x to the power 3 over 2. You may continue to change it to the third form. So the power x to the power 3 over 2, you may change it to square root of x cubed. Keep the coefficient 2/3 in front. Normally, we do not write down a 2 in front of the third. But for this example, I just need to show you that the fractional power of 3 over 2, the denominator of the power 2 is the same as square root. So when you write out your answer here, you need not have to put a small 2 in front of the third. Now we shall look at the next questions. Question 2. You want to integrate 1. So there is no x. So when you integrate, remember the formula that I showed you in the earlier slide. You shall just get x. So plus a c. For b, you have x plus 2. You integrate term by term. So here is x to the power 1. When you integrate, you should get x squared over 2. And for the second term in the integration, 2 is a constant. When you integrate, you will get 2x. Not forgetting to plus a c. For question C, this is 3x to the power of 4 minus 5x squared plus x. We integrate term by term using the same formula. You shall get x power 4, x1, you will get x power 5, then you divide by 5. Keep the coefficient 3 in front. Then for the second term, x squared. So the power 2, you add 1, it becomes power 3. Then you divide by 3. Then for the third term, so this is just x. So it means x plus x to the power 1. So when you integrate it, you get x squared. That means 1 plus 1, you get 2. Then you divide by 2. Always remember to add a c. Now we shall go to the next example. So when you have a fractions where denominator there is a single term of x, in this case you only see a square root x. So thereby you need to split it up into two terms, two fractions. So the first term is just x over square root x. Then the second term plus 1 over square root x. So we have to express it in two fractions. Then you use the index rule to simplify the two expressions. So for the first term, x divided by square root x, you shall get x to the power 1 minus square root x, the power is half. So you shall get 1 minus half to get x to the power of 1 over 2. And for the second term, 1 over square root x, it is the same as 1 over x to the power half. Then you bring the denominator to the numerator, you shall get x to the power minus half. Then we apply the formula to integrate. You shall get power half for the first term increased by 1. So half plus 1, you shall get 3 over 2. Then you divide by 3 over 2. For the second term, minus half plus 1, you shall get positive half. Then you divide by the new power of half. We change the complex fractions to simple fractions. So divide by 3 over 2. When you divide, you shall get 2 over 3. And keep the x to the power 3 over 2. Then divide by half is the same as times 2. So the power is still half. We shall change the fractional power back to the index, the normal form. So x to the power 3 over 2 is actually 1.5. So you split up, you get x to the power 1, which we don't put here. And the power half, we shall put as square root x. For the second term, 2x to the power half, you shall change it to 2 square root x. So I hope with the 3 examples consists of some question, you shall now try to do these few questions, 3 questions here. So please do this question. When you solve these questions, you will understand it better. So I will have 3 questions for you to solve in this video lecture 1. So this is question 4. Then this is question 5. Please refer to the previous example, how to integrate the expression here. So you are given dy dx, you shall get y by integrating the expression there. And the next one, okay. So that means here, you shall change it to, from the sub form, change to index form. Then you follow what I have shown you in the previous example to integrate. Then the next question, so this hand consists of 2 terms. So as usual, you change it to fractional index. Then you try to integrate. We will look at the solution in the next video. So do take time to integrate question 4, 5, and 6. So thank you class. This is the end of the video 1.